The hydrogen fueling infrastructure is expanding to support the growing numbers of fuel cell vehicles on the road. Because hydrogen is stored and dispensed and sometimes produced at a fueling station, there are additional hazards to consider besides the ones at your typical gas station. If an incident such as a leak or fire occurs at a hydrogen fueling station, we need to know how to respond. There could be additional considerations if the station dispenses other flammable fuels.
FCEVs are fueled at stations with hydrogen dispensers. The process is similar to fueling conventional vehicles. Fueling stations are equipped with many safety systems to mitigate potential hazards involving storage, production, and dispensing. These safety systems include overpressure protection, vents, and detection for hydrogen leaks or fire. The quantity of stored hydrogen varies depending on the station. Storage pressures of hydrogen range from 6,000 to 12,500 psi. The amount of compressed gas on hand for dispensing can be as little as 100 kilograms for small, light-duty stations to 1,000 kilograms for heavy-duty stations. If liquid hydrogen is stored on-site, tanks can range from 5,000 to 9,000 gallons of capacity, or around 1,300 to 2,400 kilograms of gaseous hydrogen. In comparison, the typical gasoline fueling station has between 20,000 and 40,000 gallons stored in underground tanks. Hydrogen storage is currently above ground in either transportable or fixed configurations. Hydrogen can be produced on-site or delivered to the station in either a liquid or gaseous form. Hydrogen is produced at a station by electrolyzing water or extracting it from natural gas through steam methane reforming, as it has been done in industry for decades. For gaseous deliveries, the supplier can exchange a tube trailer or swap a bank of composite cylinders. Fixed storage cylinders can also be refilled from a tube trailer. Some stations get hydrogen from an underground pipeline. Stations that receive liquid hydrogen use a double-walled steel tank that has a vacuum-insulated space in between to keep the product cool. The tank is refilled by a cryogenic trailer, which is a routine industrial gas operation. Stations that store liquid hydrogen need to return it to a gaseous state and compress it in order for it to be dispensed. Regardless of the hydrogen delivery and storage method, it is only hydrogen gas that is delivered to the vehicle. As with any fueling station, hydrogen stations have multiple safety systems in place and are built in compliance with existing codes. One such requirement is the use of emergency shutoff devices, or ESDs, which are in easily accessible locations. In a multi-fuel station, the ESDs for the hydrogen system are separate from those used for gasoline or diesel. Some stations may have a master ESD that shuts down all dispensers, regardless of fuel type. If sensors detect hydrogen levels around 50% of the LFL, or 2% hydrogen in air, when thermal cameras detect a hydrogen flame, or when a dispenser is hit or knocked down, an automatic shutdown can be triggered. In areas of the country prone to earthquakes, seismic safety is likely to be required. Stations also have electronic monitoring systems that detect other potential issues, such as an equipment failure. In each of these cases, the appropriate resources are automatically notified. This can range from a service technician to a fire department response. Additionally, due to the storage pressures involved, the cylinders require pressure relief systems, including burst discs, pressure relief devices, and safety vents. As with a vehicle, the primary safety feature on composite cylinders is the TPRD. Each cylinder has its own, which is designed to release all of the contained hydrogen in a fire situation before the composite materials that make up the outer layer of the cylinder lose structural integrity. Steel cylinders, on the other hand, don't burn, so they typically use reseatable pressure relief devices, which are PRDs that reset themselves once a safe pressure has been reached. Rupture discs may be installed as well. Liquid storage tanks use reseatable PRDs to protect against the pressure generated should the liquid hydrogen warm and revert back to a gas. This can happen if the liquid is not used quickly enough. Rupture discs are used as a secondary safety device in the event the primary system is unable to maintain a safe pressure. This could occur if the vacuum space between the inner and outer tank is lost, especially in the event of an engulfing fire. Some hydrogen releases are normal operational events, such as gas venting from the vent stack after a fueling, or venting during a liquid hydrogen tank refill. Hydrogen gas can be vented safely into the atmosphere. It is non-toxic, and in most circumstances will rise, dissipating quickly. There are also inherent safety features for the dispensing of hydrogen. This is a closed-loop process in which the vehicle communicates with the station. When the nozzle locks onto the vehicle, an initial leak check is performed. If the nozzle isn't properly connected, fueling will not start. The station periodically performs leak checks during the fueling process. If needed, the vehicle can abort the fueling. If there are any interruptions with communications from the vehicle to the station is programmed to fill the vehicle at a reduced rate and pressure. Additionally, dispensing hoses include a breakaway connection, similar to gasoline and other fuels. As hydrogen fueling stations come to your area, station developers are encouraged to have early interaction with local authorities. There will be permitting approval with the Fire Marshal's office before and during construction. Prior to the facility opening, request a site visit to become familiar with its operation. Use the opportunity to collect information for developing a pre-plan. Also, request a copy of their emergency response or safety plan. When conducting the pre-plan operation, it is important to identify the location and types of cylinders present and if there is any liquefied hydrogen storage on site. Also note the location of the hydrogen dispensers and if any other types of fuels are present. The ESDs for all fuel types should be located and documented in the pre-plan. Identify any facility signage specific to hydrogen. This could include NFPA 704 symbols or DOT placards, depending on the storage method. If hydrogen is produced on-site, there are additional considerations that should be noted on the pre-plan. For example, steam methane reforming, or SMR, will have an additional source of natural gas piped into the location. Electrolysis will have a larger electrical infrastructure to support the process, including the possibility of photovoltaic or solar power. There may be businesses in your response area that have their own private hydrogen fueling stations for fuel cell industrial trucks and forklifts. If present, a pre-plan should be conducted for those facilities. When responding to an incident at a fueling station, obtain as much information as possible as to the nature of the emergency and, if available, consult the facility's emergency response plan for specific procedures. Upon arrival, isolate and deny entry to the station and make contact with facility staff to determine the nature of the emergency. If no staff is present, use posted emergency contact numbers to reach the managing or monitoring agency. Full structural firefighting PPE and SCBA should be utilized during the investigation. Also use combustible gas meters and thermal imaging cameras to determine if there are any gas leaks or fire. A fire may be difficult to detect without a thermal imager due to the almost invisible flames and lack of radiant heat. In addition to metering for hydrogen, listen for the sound of escaping gas or a loud, high-pitched noise indicating that the relief device is activated. However, once the noise subsides, do not assume the hydrogen in the system is fully evacuated, as there may be other cylinders that haven't vented or a PRD that may have reset. If an emergency, such as a leak or fire, is present and the station's pumping, dispensing, or production equipment is still operational, use an ESD to shut the system down. If there is an incident at the station, such as a fire or leak, even if it doesn't involve the hydrogen dispenser, the hydrogen system ESD should be activated. Any hydrogen production, compression, and storage equipment, except for the dispensers, is isolated within an enclosure. Once the system is deactivated using the ESD, there shouldn't be a need to access these areas unless you need to perform a rescue operation. If this becomes necessary, the entry team needs to be in full structural PPE and on air while utilizing a thermal imager and combustible gas meter. Additionally, deploy a charged hand line to protect the entry. If access is needed for any purpose other than life safety, contact the station's provider for further guidance. When responding to a station that stores liquid hydrogen, remember that it's a flammable gas stored as a cryogen and treat it accordingly. Structural firefighting PPE and SCBA will provide limited splash protection. In the event of a fire at the station, use standard firefighting techniques on all non-hydrogen fires and protect any potential exposures. If the hydrogen is ignited and the source cannot be identified and shut off, let the hydrogen burn. For fires impinging on a liquid hydrogen tank, it is acceptable to cool the exterior with hose streams. However, avoid placing water on vents as they will freeze, inhibiting their function. This can result in an increased pressure in the tank. If steel cylinders are exposed to fire, water should be applied to cool them and reduce the potential for overpressurization and relief device activation. If composite cylinders are present, there are additional considerations similar to those found in transportation. Storage area features such as sidewalls and a roof may block access for complete cooling with water. Partial water application could cool the TPRD and prevent its activation, but not prevent damage to the cylinder itself. This could result in a catastrophic failure of the cylinder. If the entire cylinder or cylinder bank can be effectively cooled by the hose stream, use standard firefighting practices and apply water. However, if access is restricted, a better option may be to protect any exposures and allow the TPRDs to function as designed. Coordinate with facility representatives to determine when the incident has been mitigated and the station is safe to initiate any necessary repairs or to resume normal operations. Note that if a hydrogen ESD was activated, resetting it has to be done by station maintenance personnel.
Now is the best time to learn about any hydrogen refueling stations that may be in your response area before an incident occurs. Once you have identified these stations, take the time to conduct pre-plans. When you know the components, operations, risks, and safety systems of a station, you can more effectively respond to an incident.